Okay, so now I'm recording already. Recording. Okay. All right. Yeah. So wait. Let me see. Okay. So as you can see, we already deal about the displacement. Okay. If any question, please open your mic and tell me. Yeah. Right. Okay. So I already talked about this. Simple harmonic motion, circular motion, and the sinusoidal graph. Okay. If you still remember. Um, we use the this radius. Remember, the radius is the amplitude. Radius is the amplitude, and to find the displacement, because simple harmonic motion has displacement, velocity, and acceleration. So the equation to find the displacement is we use this amplitude. Find the y component of the amplitude. Yeah, so the y component of the amplitude is a sine theta, and theta is omega t. Yeah. This is the formula for displacement. Yeah, for y displacement of the simple harmonic motion as it goes up and down, up and down. Okay. So we got the formula already. Displacement against time formula, and this is the graph, right? And the amplitude is the a lah. Yeah, a. Okay, then let's go to velocity. How about the equation for velocity? We already got the equation for displacement. What about equation for velocity? Velocity, the velocity of this, block going up and down. So what's the velocity? What's the equation for velocity? So this one, the y component velocity, we use the tangential velocity. Remember the tangential velocity? V equal to R omega. The formula is V equal to R omega. And then the radius, the radius is amplitude. Like this one. The radius is amplitude. Okay, so the radius is amplitude. We substitute with amplitude. So V equal to A omega. And then if you look at here, we want the y component of the velocity only. The y component of the velocity, if you look at here, this is the tangential velocity, V equal to R omega or A omega. So the y component of this velocity is the velocity of the simple harmonic motion, velocity of the spring mass. Okay, so the y component of this velocity, yeah, is the equation for velocity for the simple harmonic motion. So the y component is v cos theta. Yeah, v cos theta. Since v is equal to r omega or a omega, so the y component of a omega is a omega cos omega t. A omega cos theta. Theta is omega t. So this is the formula for v. The velocity for the simple harmonic motion. Another way of getting this formula is we use the y component velocity. Yeah, look at here. Another way, since we know v is equal to a sine omega t, right? And then we know the velocity is, differentiate displacement over time. Remember? Because last time we velocity is ds over dt, right? Dx over dt. Now our s is y, so dy over dt. Differentiate. We differentiate displacement with time. So we differentiate. Differentiate a sine, we get a cos. Differentiate a sine, we get a cos. Differentiate. Remember, differentiate outside. The differentiate sign, we get cos, and then differentiate inside, we get another omega. We get another omega. Yeah. First we differentiate. Remember how you differentiate? You always differentiate outside first. You differentiate outside, a sine become a cos, and then you differentiate inside, we get omega. And then rearrange, we got a omega cos omega t. So this is another way of deriving this formula. Yeah, a omega cos omega t is the same as omega a lah. Yeah, doesn't matter you want a omega or omega a is the same. So there's two way of getting. Yeah, one way is using trigonometry. Yeah, trigonometry to get this formula, or the other way is you differentiate. So actually, this is not so important. Yeah, to differentiate this formula. Yeah, if you don't understand, also never mind. The important thing is we must know the formula. We must know this formula. Yeah, formula for velocity. That's enough lah. How to differentiate? You can, if you understand, then that's good. Yeah, if not understand, doesn't matter. Yeah, we pay attention for other part. Yeah. So one way is trigonometry, one way is differentiate. Okay, and then we go to another one, formula for acceleration. Formula for acceleration, we know that you see, acceleration is always towards the equilibrium. Remember? Towards the equilibrium. Yeah, and then we already learned about centripetal acceleration. Remember centripetal acceleration? And centripetal acceleration formula is AC equal to R omega square. Remember we learned the AC. We learned about AC is equal to V square over R. Or you can also write as R omega square. Okay, and then R is amplitude. Yeah, because we always regard the radius as amplitude. Radius as amplitude. Yeah. So our R is amplitude. So we just put radius R omega square is amplitude omega square. Then we always find the Y component. You see, we always, no matter for displacement, we always want the Y component. Only the Y component of the amplitude. We want the Y component of the amplitude. For velocity also, the tangential velocity, we also only want the Y component of the tangential velocity because we are talking about spring mass system going vertical motion. What? Okay, so we only want the Y component. See that? The displacement also Y component, velocity also Y component, and the acceleration also Y component. Acceleration is towards the equilibrium. See that? And centripetal acceleration is towards the center of circle. So A equal to R omega square. Radius is amplitude. Okay, amplitude. So AC is A omega square. So now what is the Y component? The Y component of the AC. So this is sine theta. Remember that? Sine theta equal to AY over opposite over hypotenuse. Sine theta. So see that? Where is it? So yeah, because it's going downward, opposing the displacement. So that's why I got negative sign. So AC sine theta. AC sine theta. Yeah. Or A omega square sine theta, because we want the Y component. Yeah, not the cos theta lah. Cos theta is the X component AX. We want the AY. So AY is sine theta lah instead of cos theta. Okay. So why negative? Negative because it's opposite the displacement. Or we can use sine theta is sine omega t, and then AC is A omega square, omega square A. Okay, another way is we differentiate. Just now we got the formula for velocity kan? V equal to A omega cos omega t kan? Okay, we proceed with this formula. Yeah, V equal to A omega square cos, wait. A omega cos omega t, sorry yeah. Relax class, just relax. This differentiation is just for general knowledge lah. Not later on you see during the problem solving, we're not going to differentiate. We're not going to derive any formula. Yeah. So this is just for your general knowledge. Yeah. But I have to teach it because it's in the syllabus. Okay. So acceleration is dv dt, right? We can differentiate also. Differentiate. Differentiate. First we differentiate. Remember, we always differentiate outside. Okay. And then this is a constant value. So when you differentiate, nothing happens. So you still have A omega. When you differentiate this cos, become negative sign. Remember that? We get negative sign. So this is what we get when we differentiate outside. We differentiate cos, we get negative sign. Yeah, we get negative sign, and then we differentiate inside. After that, we differentiate inside. We get another omega. We get another omega because we differentiate against t. We differentiate against t, so we only take the constant value. Yeah, differentiate, we get omega. This is differentiation. So in mathematics, you must master topics about differentiation. Then only you can understand. Differentiate omega t, we get omega. So afterward, we this one go to the front. So a equal to negative a omega square sine omega t. So that's the formula for someone just come in. Okay, yeah, everybody's here. Yeah. Okay. All right. 1 second. Yeah. So class, do you see that, class? So you also get the formula for. Hold on a second. Okay. So we also got this formula for see, same formula, isn't it? One way is we take the trigonometry, we get the same formula, or we differentiate, also can get the same formula. See, a omega square or omega square is the same lah. Okay, so we get the formula for acceleration for simple harmonic motion. Later we're going to use this formula to solve some problem. Okay, and then negative. Later I will. Okay, wait. Okay, class. One thing I want to show you here is just now you see, where is it? You see, class, for maximum value, the y maximum, if you look at go back to the formula for displacement, we have y equal to a sine omega t, isn't it? So this a is the y maximum. Y maximum is amplitude. This is very important. Y maximum is amplitude. Yeah. So the graph here, the maximum is amplitude lah, and you can see it's a sine graph. It's a sine graph. And then look back. The maximum value of displacement is amplitude. Okay. And then look to the velocity graph. Velocity graph. Okay. Look at the equation. Sorry. You can see here this maximum here. Okay, the V maximum is a omega. A omega. Okay, the V maximum is a omega. Just now y maximum is a, V maximum is a omega, and then what's the graph? What's the graph for this velocity graph? You can get a cos graph. He didn't show here, but I draw for you. Yeah, velocity versus time. You get a cos graph. That means cos graph means like this. Cos graph means like this. Okay, so you get a period, 2 period, and here is a omega, and below is negative a omega. So it's a cos graph for velocity graph. Is a cos graph. For displacement graph is a sine graph because the equation is sine and the maximum is a. Understand, class? Yeah. So here the V maximum, here is the V maximum value lah. V maximum. V maximum is a omega and it's a cos graph. And how about the acceleration graph? Acceleration graph is, if you look at here, the maximum is, look at here, the maximum is here, this one. The maximum, A maximum is A omega square. A omega square. Okay. The negative is just about the direction only. A maximum is A omega square. Okay. And the graph is a negative sign graph. If you want to draw a graph of velocity graph, I mean acceleration graph, acceleration time graph, the graph is a negative sign graph. Negative sign, that means it's like this. So I get period, 2 period, and what is the maximum acceleration? What is the maximum acceleration? A omega square. A omega square. Understand, class? Okay, for acceleration graph is a negative sign graph and the maximum is A omega square. For velocity graph is A omega, is a cos graph because the equation is cos. And for displacement graph is a sine graph and the maximum is A amplitude. Okay, it's a sine graph. Sine graph, cos graph, negative sine graph. Okay, now just now we have actually last time I teach already all this thing. I teach already, yeah. This is in the past lah. Yeah, I teach already. Maximum, A omega square. Okay, wait. Let me show you. Yeah, this acceleration versus displacement. Okay. I just want to list out. So you have. I want to summarize. Displacement versus time graph. What is the equation again? Y equal to A sine omega t. Velocity versus time equation. What is it? Velocity equal to A omega cos omega t. You must memorize, class. You must memorize this one. And then acceleration is what? A equal to negative A omega square sine omega t. Okay, and you can see here is the maximum value. Yeah, A omega square. These are the maximum value. Yeah, the one I highlight is the maximum value. Maximum value for displacement, maximum value for velocity, maximum value for acceleration. Okay, now I already have equation for displacement versus time, velocity versus time, acceleration versus time. Now I need two more equation, which is velocity versus displacement. Just now is velocity versus time. How about velocity versus displacement? And also acceleration versus time. What is the acceleration versus displacement? Another two formula you haven't learned is what is the formula for velocity versus displacement and acceleration versus displacement. See the variables different? This is velocity versus time. How about velocity versus displacement? Acceleration versus time given. What is the formula for acceleration versus displacement? Okay, if you look at here, I do this first. Acceleration versus displacement. You look at here, y equal to A sine omega t. Compared to this one, A equal to negative A omega square sine omega t. You see what's the similarity here? A sine omega t with A sine omega t here. Do you see what's the similarity here? A sine omega t and A sine omega t. So I can substitute. A equal to what again? Negative omega square. Negative A omega square. We keep it. A sine omega t, we change with y. Okay, so we got the formula for acceleration with displacement. Yeah, do you see it, class? Acceleration with displacement, we get in the equation. And do you remember this equation, class? Do you remember this equation? This equation. This is actually the this formula. Remember this formula, class? Do you see this formula somewhere else? Yeah, This is the one. The simple harmonic motion. Nah, do you see that, class? A equal to negative omega square y. This is the simple harmonic motion definition. A equal to negative omega square y. What does it mean by A equal to negative omega square y? It means that acceleration is proportional to displacement. Acceleration proportional to displacement. But acceleration is negative y. Negative means opposite y. Acceleration is proportional to displacement, but it is opposite, always opposite the displacement. Acceleration always opposite displacement. If like the the diagram, you see that, like this the spring, the displacement is going up. At this position, displacement is going up, but if you look at acceleration, acceleration is going down. Why is going down? Because the spring is being compressed. The restoring force is to push the object back to equilibrium. Force is because the force is downward. Force is downward, so acceleration downward. So you see, acceleration downward, displacement upward. They're opposite. Opposite. You see that? As displacement upward, acceleration downward. So they're opposite. So that's why A is negative y, opposite, but proportional. So this is what you mean by the definition of SHM. Definition. Okay. So now, how about velocity? We get one more formula: velocity versus displacement formula. Velocity versus displacement formula. How to get? Very simple. I'm sure everybody here already learned about trigonometry. You know this thing. Sine square. You can use this formula also here. Velocity versus displacement. You can use this way to find the equation. I show you a simpler way. My own way. Yeah. I'm sure everybody of you learn this: sine square theta plus cos square theta equal to what? Trigonometry. Sine square theta plus cos square theta equal to what? 1, isn't it? Trigonometry identity, right? Identity. Okay. So look at here. When theta is omega t, you can take it like this lah. Sine square omega plus cos square omega t equal to 1. Okay. So what I do is I change this yt formula and vt formula. I get the sine omega t and cos omega t. So see what I do. Yeah. See what I do. Okay. So this formula become what? So sine omega t, what do you get? Sine omega t is equal to y over a. Okay, and then this formula, what do you get, class? This formula cos omega t. What do you get? Cos omega t is equal to v over a omega. Kan? Betul tak, class? I just a go below, a omega go below, so I got this, and then I substitute here. I substitute there. Yeah. So what do I get? So sine omega t is y over a. So y over a square plus cos omega t v over a omega. So v over a omega square equal to 1. So what do I do? Because you got square here, so you must put square there, and then so after that, what do I get? Need some space, so go a bit above. So I multiply a omega, okay, I get y square a square plus v square over a square omega square equal to 1. Okay. So what do I do is I multiply a omega. I multiply a square omega square. So I multiply. So y equal to y square. Yeah, correct, yeah. Y square, so I multiply, I get like this, and then sorry, and then I plus v square, and here I multiply a square omega square. Okay, class? Okay, I multiply, what do? I multiply a square omega square, both side. I multiply both side, so I get this. Okay, so what's next? So I v square equal to a square omega square minus this one go to the other side. It become what? It become y negative y square omega square. Okay, I need some space, so go below, you know. So what do is I can factor out the omega square. So a square minus y square, okay, v square. So what do is I square root both side. I don't want the square, so many square. And remember, when you square root, you must have plus, positive, negative. You don't simply just square root and without the positive, negative. You must have a positive, negative sign. And in the end, what do I get? I get v equal to plus minus, and then the omega square root, you get omega, and then square root a square minus y square. Yes, this is another formula. I got it already. That's the formula for what? For velocity versus displacement equation. See, is it same? Is it same as this one? Yes, you see, it's the same. I need to drag it here. See, is it the same, class? V equal to plus minus omega square root a square minus y square. Is it the same as this one? Yeah, v equal to plus minus omega square root a square minus y square. So this is another formula. For velocity versus displacement. So how many formula you have here? Displacement time, velocity time, acceleration time, velocity displacement, acceleration displacement. So this formula you are going to use later. Yeah. How to derive? Not so important actually. Yeah. But it's the process. I need you to, how do I get it? Sometimes we learn something, we don't have to memorize everything. We must know how to do it. Yeah, we must know there is a way to do it. Yeah, you remember somewhere and you want to really know it, Google it. Yeah, everything is on the net, how to do it. Yeah, you can find my YouTube. So later we're going to use this formula to solve the problem. Yeah, so don't worry so much. Okay. So these five formula we're going to use. Yeah, 5 formula we're going to use. So now this one. Now it's about energy. Yeah, energy. So I'm going to continue with this one, class. So energy. Yeah, we know that. Remember my last time I show you the where is it? I show you the spring mass system. The spring mass system, remember I show you my animation there. So the maybe I show you again never mind, I can show you again my animation there. Okay, yeah, so where is my animation again? Yeah, this one. Class, can you see, class? Can you see? So you see, these two bar, you have a green bar and red bar here. The green bar shows the elastic energy in the spring. Yeah, not so smooth. See that? The green bar shows the elastic energy in the spring, and then the red bar shows the kinetic energy in the block. this energy always interchange themselves, and they always have the same amount. You see that? When one goes to maximum, the other go to zero. When one is maximum, one is minimum. You see, maximum, that one is minimum. See that? Cannot stop it, yeah, never mind. So it always when one at maximum, another one at minimum. Yeah. So it's between potential energy, elastic potential energy in the spring, and kinetic energy of the block. They always interchange themselves. Okay. So close this one. Yeah, because it's lagging, causing lagging in the videos later. I must close it. Okay. So that's why we're going to learn about potential energy and kinetic energy. Remember? Where is the potential energy? Where is the potential energy? It's the potential energy of the spring. It's the elastic potential energy stored in the spring. The elastic energy, not about the gravity. It's the elastic potential energy stored in the spring. But for spring mass system lah. But if for pendulum, simple pendulum, then it's gravity. If simple pendulum is gravity. For spring mass system is elastic potential energy. But for kinetic energy is what? Kinetic energy is the kinetic energy of the object. So this kinetic energy is what? Kinetic energy in the block. So the elastic, but the potential energy is in the spring. The kinetic energy is in the block. Understand? So how to find, what is the formula? We must know the formula for elastic potential energy in the spring. And this is the formula. How do you get this formula? So elastic potential energy in the spring, the general formula is half kx squared. Remember? Elastic potential energy is half kx squared. K is the spring constant. And we are not using x, we use y. Y is the displacement from equilibrium position. In fact, this displacement is either, is either compression or extension, isn't it? The displacement for equilibrium actually is the compression or extension. So yeah, we use y. Yeah, we just change the symbol, become y, and then so the formula is half ky square. Yeah, we just change from y, x become y. Yeah, it's the same. Yeah, x and y is the same actually, but we use y because we use y component. Okay, so y is the displacement, or we call it the compression or extension of the spring. Okay. And K is equal to m omega square. K is equal to m omega square. So this is another formula. Yeah, this is another formula. You must remember K is m omega square. Yeah, K equal to m omega square. So we substitute K equal to m omega square. We get this formula, half m omega square y square. So this is another formula. Another formula for elastic potential energy. So add to our collection. What formula? So now we have formula for elastic potential energy. Elastic potential energy. So elastic potential energy in the spring versus displacement is, what's the formula again? Tell me. Is half m omega square y square, or you can write it as half ky square. Okay. So we have the sixth formula. We already have 5 formula just now, kan? 1, 2, 3, 4, 5. Now we have 6 formula. Potential energy is half m omega square y square, or half ky square. Now the next formula is the kinetic energy. Kinetic energy of the block is kinetic energy of the block is half mv square. Half mv square. Remember the kinetic energy. And V formula, V versus Y formula is plus minus omega square root A square minus Y square. This is the formula that we've derived just now. This formula V equal to plus minus omega square root A square minus Y square. We substitute this formula into the V here. We substitute into V here. So the plus minus become positive only. Yeah, no more negative because square, you have square. You know, the V here got square. So the negative becomes square, so only positive. And then omega square, you get omega square. And then the square root, hilang. No more square root. So we have A square minus Y square. So this is the formula for kinetic energy of the block. Kinetic energy versus displacement equation. So add to our collection of formula. So kinetic energy of the block versus displacement formula. So kinetic energy of the block is half m omega square. What again? Sorry, no more square root. Is A square minus Y square. Or you can write it as half mv square. Okay, class? So this is the formula that we're going to use. All this formula we provided in the list of formula. Okay, so this is the thing, yeah, half m omega square A square minus Y square. But you see, very similar. Potential energy is only Y square, but for kinetic energy it got A square minus Y square. The front part is the same. You see that? This the half ky square is the elastic potential energy of the spring. Half mv square is the kinetic energy of the block. Okay, so yeah, you got another formula already. Now last formula is the total energy formula. Here total energy didn't show you, but it show you the formula. What? Okay, the total energy E is equal to half m omega square A square. How do you get this formula? Because as I said, for a spring mass, spring mass system, you know, so inside the spring it have elastic potential energy. Inside the block it has the kinetic energy. Yeah. So you know the block is going to and fro, you know, to and fro. So in the spring has elastic and kinetic. So all the time the total energy is constant. The total energy is actually elastic potential energy in the spring plus kinetic energy. So you plus them together. So you see the formula for this one, half m omega square Y square plus half m omega square A square minus A square minus Y square. Okay. So class, you see half m omega square Y square plus this one. That means you see here class, here is half m omega square Y square, and then here got half m omega square negative minus Y square here. You see that? Kalau kita kembangkan half m omega square this one become negative half m omega square Y square. That means yang depan ini kena cancel by this one. You see that class? Kalau kita kembangkan, ini darab keluar, kita kembangkan. Ini kena cancel. So that means in the end what do we get for the total energy formula? This is the total energy formula of the whole system, you know. The total energy of the whole system. That means it's the energy in the spring plus kinetic energy of the block. So that means this is the total energy of the whole system. Total energy of this whole system. We call the mechanical energy lah. The total mechanical energy of the whole system. So what's the total energy? So we plus this together, so we get what? Half m omega square A square. Because ini sudah kena cancel oleh ini, So we get the total energy formula is half m omega square A square. And you see here, class, and this is if we look again the formula between the potential energy formula and kinetic energy formula. This y and y here is always changing. Yeah, is always changing. Yeah, this y here is always changing because displacement is changing over time. Because displacement is changing over time because oscillation mah, kan? Benda ini oscillate mah. Look at my oscillation again. Where's the block? Nah, yeah? The y is changing mah. See the blue line? The y is changing. The y is changing mah. The y is always changing all the time. Y is not constant. Y is not constant. Y is always changing over time. So that's why the kinetic energy, you see the red bar always changing. The green bar always changing also. So the displacement always changing with time. Yeah, the displacement always changing with time. So that means the potential energy and kinetic energy always changing. So it's not constant. The potential energy is not constant, always changing. Kinetic energy also always changing. It's not constant, they're always changing. But look at the formula for total energy. Ada y tak? Ada y tak? Tak ada this. Dia hanya ada amplitude. So it's all constant value. So the total energy of the whole system is always constant. This m is the mass. Yeah, look at here. The total energy, the m is the mass. Omega is the angular frequency. Yeah, and this is the amplitude. All these are constant value. So the total energy of the whole system is always constant. Always constant. So this system we assume to be what? Since dia kata total energy is always constant, that means kita assume apa? No damping. No damping. No damping, that means what? No loss of energy to the surrounding. No loss of energy to surrounding. So that means kalau ini that means kita kata we assume the surface to be no friction, no air resistance. We assume to be ideal system. Ideal, tak ada air resistance, tak ada friction, no, you know damping? Tahu damping tak? Tahu kan? We assume no air resistance, no friction. So that means the total energy is always constant all the time. That means that is our assumption for our simple harmonic motion. Yeah, our assumption for our simple harmonic motion. Remember? Simple harmonic motion is defined as a periodic motion without, without loss of energy. Without loss of energy. We assume the oscillation oscillate forever. That means no damping. It will oscillate forever if your total energy is always constant all the time. If your total energy is always constant all the time, no loss of energy to surrounding, so that means we assume the elastic energy only change to kinetic energy, and then after some time kinetic energy change back to elastic energy. So there's no loss of energy due to friction, become heat, become to overcome the air resistance. No, yeah, the energy only interchange between these two. Dia hanya bertukar antara ini dua sahaja. Understand? Sebab kita total energy tidak include energy loss yang lain, ya, heat energy tak ada. Kita punya total energy hanya ada antara spring dengan elastic energy of the spring atau kinetic energy of the block saja. So we assume the energy will be constant all the time, so this thing will oscillate forever. oscillate forever. That's our assumption for our SHM. Oscillate forever, no loss of energy. No loss of energy to surrounding. Total energy is constant all the time. Okay, so until here, I want to see your response, class. Do you understand, class, what I'm saying? Boleh? Boleh lah. Okay, tak ada 100%, ada 70%, saya pun happy lah. Sebab ini semua derivation saja. Kita belum masuk lagi apa? Problem solving. Ini cuma introduction saja, ya. Okay, baik. Kita tengok, ya. So kita sudah tengok ada berapa formula di sini, kelas. So add to our collection, kita ada berapa formula kena tahu. Total energy is equal to U plus K, which is equal to apa formula dia? Half M omega square A square. So kelas sebenarnya tak susah juga. Kita tengok balik formula. Displacement ialah A sin, velocity ialah A omega cos. Kalau acceleration ialah negative A omega square sin. Dia jadi ini sin, ini cos, ini negative sin. Dan dia punya amplitude just ubah kepada A omega square. Tidak susah kan? Lepas tu kalau V punya formula ialah macam ni lah. You lama-lama guna pun akan ingat lah. Plus minus omega square root A square minus Y square. And then ini V dengan Y punya formula. Ini A dengan Y formula ialah A equal to negative omega square Y. Lepas tu potential energy, kinetic energy formula lebih kurang sama. Cuma potential energy dia adalah guna Y square. Kinetic energy guna A square minus Y square. Depan sama. Half M omega square. Just ingat, ada satu benda kena ingat di sini, ya. K adalah M omega square. Ini kena ingat, ya. Another formula here. K is mass omega square. And then total energy formula, kalau potential guna Y square, kinetic guna A square minus Y square. Kalau total energy guna A square je. And it's always constant. Constant. Yang dua tadi itu, yang dua ini changing over time, ya. Potential and kinetic changing over time, but total energy always constant because we assume to be no loss of energy, ya, no damping. Itu sajalah kelas. Then dia ada graph dia, kelas. Ini potential energy, kinetic energy, total energy, ada graph dia. Inilah graph dia, kelas. Graph dia. So how to draw the graph, class? Very easy. Let me show you. Let me magnify. Let me draw for you again lah. No, tiada hal. Saya boleh lukis. So, ini ya, dia punya di sini ialah guna Y, di sini guna Y. Yang paksi X guna untuk displacement, paksi Y untuk energy. Either total energy ataupun potential energy ataupun kinetic energy. So di center ini ialah equilibrium. Center ialah ini ialah equilibrium position. Equilibrium position. Kalau di sini, ya, di sini ialah amplitude. Positive amplitude, di sini ialah negative amplitude. Negative amplitude. So class, macam inilah. Mungkin saya buat satu begini, ya. So kalau blok di sini equilibrium lah, ya. Spring tak ada apa-apa, kan? Spring tak ada apa-apa. Tapi kalau dia kena compress ke sini, maka banyaklah elastic energy di sini, kan? Kalau di sini dia banyak extension pula di sebelah sini, kan? Betul tak? Okay. Mia, wait a second. Ada orang call bah. Sekejap lah. One second lah. So. Boleh. Datang. Thank you. Okay, so class, Okay, so you see here you see okay, so you see this one the total energy is always constant. Total energy is always constant all the time. I'm finishing already almost. The total energy is always constant. So that's the graph for total energy. Yeah. And the value is here. The value is the total energy lah, half m omega square a square. Here. And this is the amplitude. Yeah. Here is this the amplitude. Here also amplitude, but negative amplitude lah. Sini negative amplitude. Yeah, hold on a second, class. Hold on a second. 等下有人要进到先，他一下子要来了。Okay, okay, class, yeah. I'm coming back. Yeah, lagi give me 5 more minutes, yeah. Okay, so come on. So here this is the total energy formula. Yeah, total energy is half m omega square a square. Yeah, half m omega square a square. Hold on a second lah.不要拿，放在那边。Okay, class. Yeah. Okay. So you still here, class? Okay. Come Alright. So total energy is always constant. Yeah. No matter where is the block. Block di sini kah, block di sini kah, block di sini kah. The total energy is always a constant graph. There's a total energy graph, and the value for the value for the total energy is half m omega square a square. And then dia apa tu? Dia kalau elastic energy punya formula apa? Elastic energy dia paling maksimum di bila? Kalau di sini the elastic energy ialah kosong, betul tak? Ataupun jangan lukis di blok. Di sini hold on a second, let me draw. Kalau di sini elastic energy ialah kosong, kalau di sini elastic energy maksimum kan, betul tak? Kalau di spring, betul tak? Kalau maximum compression dia punya elastic energy paling maksimum, ataupun maximum extension dia punya elastic energy paling maksimum. Tapi kalau di equilibrium dia punya elastic energy ialah kosong, ya, sebab no extension, no compression. So maksudnya elastic energy paling besar di sini. So saya tanda di sini. Paling besar di maximum compression, paling besar di maximum extension, dan kosong, elastic energy kosong bila di equilibrium. So maksudnya graf dia beginilah. Ini graf dia. Ini graf dia, the elastic energy of the spring. Okay? Dia graf senyum. Kalau elastic energy of the spring, this is the elastic energy in the spring. Graf senyum, dia maximum di amplitude. Elastic energy maximum di amplitude. Tapi kalau equilibrium means no extension, no compression. So elastic energy adalah kosong. Tetapi kalau di equilibrium, apa yang maksimum? Ya? Mestilah blok paling, ya, potential energy di kosong. Di mana pergi energy? Energy pergi mana? Mestilah energy pergi ke blok. Betul tak? So kalau di equilibrium, kinetic energy ialah maximum. Kalau di sini kinetic energy maximum of the block. Kalau di block kinetic energy maximum. Tapi kalau di amplitude, kinetic energy jadi kosong. Sebab apa? Sebab dia berhenti kan? Kalau di amplitude, blok itu dia berhenti. Dia berhenti sekejap, tukar direction. Kalau di equilibrium, kinetic energy maximum. So dia punya graf macam mana, kelas? kalau kinetic energy of the block. Kinetic energy of the block dia adalah di sini, ya, di sini kosong, di equilibrium maximum. Kalau di amplitude dia kosong. So graf sedih. Graf yang tak senyum lah. So ini this is the graph for kinetic energy of the block. Faham tak, kelas? So tengok ada titik persilangan di sini kan? Ada titik persilangan di dua tempat kan? So this is the position when the elastic energy of the spring sama dengan kinetic energy of the block. So it can be this is the position when bersilangan itu means position where elastic dengan kinetic dia sama nilai. Okay? So kinetic energy of the block is maximum at the equilibrium. Sebab apa? Sebab all the elastic energy in the spring sudah pergi ke block. Bila di equilibrium. Faham tak? Sudah pergi ke block. So maksudnya dulu, okay, maksud apa, kelas? Maksudnya when amplitude lah, ataupun when y berada di maximum, berada di amplitude, ya, u adalah maximum, u adalah apa formula dia? Apa formula dia, kelas? U apa formula dia? Half m omega square y square kan? So bila y adalah amplitude, y adalah a, gantilah y dengan a. Kan formula u ialah half m omega square y square kan? Betul tak? So bila y di amplitude, masuklah y dengan a, so dapat apa? U maximum ialah apa? Half m omega square amplitude square. So tengok, bila di amplitude, u maximum ialah half m omega square amplitude square, which is the formula for the total energy. Nampak tak? Kelas? So maksudnya ketika itu dia punya all the energy of the system semua berada di spring. Ya? Formula for total energy ialah apa? Half m omega square amplitude square kan? So bila di amplitude, all the energy is berada di spring. So maksudnya apa? Kalau di amplitude, dia adalah macam ini. E total equal to U maximum tambah, okay, total energy kan dia adalah U plus K, betul tak? So bila di amplitude, dia adalah U maximum tambah kosong lah. Kelas? Faham tak? So semua tenaga itu tersimpan dekat spring. So it's half m omega square a square. So okay, kalau bila di equilibrium pula macam mana? Kelas? At y equal to minimum, which is 0. When y equal to minimum equals 0, so what happened, class? So look at the u. Tengok formula u. U adalah equal to half m omega square y square kan? Betul tak? Bila y kosong, so u berapa? U pun kosong lah. Betul tak? Tapi kinetic energy punya formula berapa? Kinetic energy kan half m omega square a square minus y square kan? So gantikan half m omega square y square, apa tu? A square minus y square. Gantikan y dengan kosong. So apa, kelas? You tell me. Half m omega square a square. Sebab y square sudah jadi kosong, so a square. So kan masa itu kan kinetic energy maximum lah. Betul tak? Nah, kinetic energy maximum, which is sama dengan total energy. So masa di equilibrium, when y equal to 0, that means it is at equilibrium. So at equilibrium dia adalah dia punya U dia adalah kosong, tapi K dia maksimum. Nampak tak kelas? Let me see your hand. Whether do you understand kelas? Begitulah ya. So bila ini di amplitude. Ini bila di amplitude. Bila di amplitude dia punya U maksimum K kosong. Tapi bila di equilibrium dia punya potential energy in the spring sudah tukar semua kepada kinetic energy in the block. So tak ada lagi tenaga simpan dalam spring. Tak ada lagi tenaga simpan dalam spring. Kita guna formula pun ganti Y dengan kosong. Kita dapat kosong. U pula K pula dapat maksimum. Dapat formula total energy lagi. Tengok amplitude U maksimum, K 0. Tapi kalau di equilibrium U apa yang kosong? U pula kosong, K pula maksimum. Macam itulah. Tengok balik itu saya punya simulasi tu. Tengok dia bermakna tak sekarang? Tengok dia mana. Okay. So see which itulah elastic energy. Tapi kita paling simple lah, kita tak consider apa. Tengok ni. Kinetic energy maximum di, tengok red bar itu maximum di bila? Red bar itu maximum di equilibrium, tapi zero at amplitude. See that? Block punya kinetic energy. Macam itulah. They always interchange, the green bar and red bar, they always interchange each other. Total energy is half m omega square a square. Macam itulah. Okay. Ini apa kita kata contoh yang paling simple lah. Kita belum consider lagi itu energy loss. Hilang pula semua benda ni. Mana? Kita belum lagi consider tentang damping lagi. Damping we don't consider, kita tak consider lagi damping energy loss to the surrounding lah. We only consider the energy always maintained inside the system. No energy loss to surrounding lah. No energy loss to surrounding. Okay. Okay. So in the end, in the end, I will just talk about this. Inilah formulanya yang tadi kita sudah derive tadi. Kita akan guna balik formula ini semua. Ada dalam table ni. Nampak tak? Y maximum ialah A. V maximum ialah A omega. Acceleration maximum ialah A omega square. Macam tu. Dan I think saya sudah habis. Tinggal ini senanglah. Kalau simple pendulum, dia adalah simple pendulum punya period, ini formula dia 2 pi square root L over gravity. So kalau simple pendulum, it depend only on length and gravity. It's independent of mass. So sebab kalau you ambil mass kecil, let's say you ambil 1 kilogram punya dengan satu lagi pendulum yang 100 kilogram, mana punya oscillation period lebih lama? Mana punya period lebih lama? You rasanya? Same period. Is independent of mass. Ini penting kelas. Independent of mass. Kalau simple pendulum lah, tak kira you guna mass apa, dia period tetap sama kelas. Macamlah you pergi buayan, pergi main swing dekat taman apa? Taman permainan lah. Suka main swing tak? Suka main swing. Macam saya ataupun orang yang kurus, budak kecil dengan budak yang besar badan, orang dewasa dengan budak kecil, budak dewasa pula. Orang dewasa dengan budak kecil, siapa punya period lebih lama? Sama kan? Okay. Sama ya. Kalau mass pula M over K lah. I think sampai sini sajalah ya, kelas. Thank you very much. Sampai sini saja. Thank you. Hello. Sampai sudah. Di taman. Yes, lot 8. Ya, 2 tingkat tu, yes. Ya, boleh keluar sudah.
Thank you,
Terima kasih.
sir.
Ya, sorry, sir. Tadi dalam kelas lah. Ya, saya di rumah sekarang. Di lot 2.
Thank you,
Thank you,
sir.
sir.
Saya plate kereta saya
Thank you, sir.
di LE. Okay, thank you, class. Okay, bye.